Hello and welcome. In this video we are going to look at how to configure a admittedly quite obsolete firewall called iptables. So we're going to use this to start looking at how you can configure a firewall on your Linux servers. I'm assuming you have a basic understanding of how iptables works and how it displays rules. If not, the video I made right before this one was all about getting iptables to display what it had and how to interpret the output that it was showing you. So if you aren't comfortable with that, I would strongly recommend you go watch that video. I'll be here when you get back. What we are going to do, though, the reason we're doing this is so that we can start to control the traffic that's allowed to reach our machines. And just a warning before I do this, I would not recommend at all using iptables on a production machine these days. There are other, better, newer firewalls that, do this job better. Firewall D. Use it instead. This is, however, useful when you're first learning a firewall, so you get a better grasp of what a firewall is doing, and the rules that you write in iptables that we're going to cover, you can actually reuse those in Firewall D. So this isn't just a waste, as students have been known to ask me. If we ever need to completely wipe out the rules that are in our iptables and maybe go back and restore our previous settings, it can sometimes be useful to just wipe out everything in a chain or in the entire firewall. So iptables-F would delete all of the rules in all of our chains. It just wipes everything out. That is almost never going to be what you want. iptables-F and the name of a chain wipes out all the rules in a particular chain. If you do either of these, all of the chains that have been emptied out, they will now only be using the default policy that exists in that chain. So, accept, reject, drop. So let's change that policy. Now, we already saw in the previous video that the default policies that exist when you install iptables are to accept all traffic. So if I went over here to my machine and I said sudo iptables-l, those default policies are set as accept. So if I did something silly, like flush all the rules in my input chain, I would then be saying, accept all of the traffic that is sent to this machine. Now, I'm reasonably comfortable doing that with this machine because it exists inside a virtual network that is, the firewall that my host is set up to not allow other people to initiate traffic into here, and the rest of my network is set up to block traffic to getting into this virtual network. So for a few seconds, I'm reasonably comfortable doing that, but generally, flushing all the rules in your firewall is a really bad idea. You might do it for just a few seconds to see, is it the firewall that is blocking this traffic? And then immediately, once you determine whether it is or not, reload your firewall, get all your rules back, and diagnose the situation either way. But you don't flush your firewall and leave it that way. That's a great way to let somebody else take over your machine. So I'm going to say iptables-F, and I'm going to wipe out all the rules on the firewall, all the rules in the chains on this machine. If I do my display, there we are. I have my 3 chains. They still exist. They are not affected by that. They have their default policies. that are not affected by that flush. This machine is now, well, I've effectively turned the firewall off, which is a terrible idea. So I'm just going to restart it to get all those rules back. Oh. Sudo iptables-l. There, I reloaded. All my rules are back. Great. So before I do that again, well, this machine, it's a leaf node in my network. Nobody should be sending traffic to it and expecting that traffic to arrive anywhere else. So I can change my forward policy to drop. And I do that with iptables -P, the name of my chain, whichever chain I want to change, and the rule that I want, or the target that I want to use. So I'm going to say sudo iptables-P for default policy forward drop. And if I list my forward chain, we can now see the default policy is drop. If a packet shows up and the rules in this chain don't say what to do with it, we will now just throw it away without response. I'm going to do that to my input chain as well. And if we list input, there we are. My default policy is drop. So now I'm actually better protected by that policy than I am by the last rule in each of these chains that says reject anything I didn't expect so far. Depending on who you talk to, some people will say your default policy should be drop. I am one of those people. That way, all you need to do to keep this reasonably secure is anytime you do want to set up a new type of traffic that you allow, or want to allow, you just add a rule to your firewall that says this particular traffic is allowed. And anything that you've forgotten about, anything that you didn't think of, if somebody tries to use that to connect to your machine, it is just thrown away. The alternative to this, some people do say set the default policy to accept. Those people are wrong. You absolutely should not be doing that. That is just a completely unsecure way to run your system because you will never remember every possible thing that you should be blocking. So do not do that. Use a default policy of drop and add rules that say, this is traffic that I expect, allow this through. This is traffic that I expect, allow that through. This is traffic that I expect, but only from my local network. So if it's from my network, allow it through. If it's from anywhere else, this rule doesn't match, so let it go to the default policy. Now, when we're going to start creating our rules, so, we do want to have rules that say, okay, this is traffic I want to allow through. There's a few things that we need to keep in mind as we start writing that rule. So number one, what chain should this rule be going in? And again, I'm going to limit this to just input, forward, and output. Again, there's more, but I'm not going to talk about them. So if this is traffic that people are sending to my machine, that, it's a service hosted on this machine, that rule is going to go in the input chain. If it's traffic that my machine is sending out, or I'm responding to traffic that was sent to me, that goes in the output chain. And if it's traffic that somebody sends to this machine to get relayed on to some other machine, that goes in the forward chain. I'm going to skip the, I'd say, second bullet point, but it's actually fourth one for a moment. We also need to think about, what am I going to do with this traffic? Again, I'm going to limit this to just accept, drop, and reject. There are more targets than these, but these are the ones you're going to be using all the time. And once you understand these, it's pretty easy to, on your own, learn about the others later if you want to. So if I want to allow this traffic through, my target is going to be accept. If I want to take this traffic and just throw it away and not respond, I want drop. If I want to block this traffic, but I do want to respond to the sender, I might use reject. Generally, a good way to decide between drop or reject is, do you want this other machine to know that you exist? So if it's traffic originating from other machines in your own network, it's probably safe to use reject so that you can troubleshoot a bit more effectively. But if it's traffic just coming from the internet and you haven't explicitly accepted it, yeah, you probably want to throw it away and not respond. And jumping back up to the thing that I skipped, what traffic are we trying to match? And that's what the next slide and quite a bit of this lesson is actually going to be about, is what aspects of this packet am I looking for? So what kind of traffic am I trying to accept or drop or reject? And there's quite a few different options that you can use to specify these options to match a packet. There's, I'm going to say hundreds, but I haven't counted in some time. So I've limited this to just some basic ones that you'll see pretty much all the time and that are pretty easy to understand. It's pretty common to be looking at the source address. Who sent this traffic? And you could, the address that you put in here, this could be an individual machine's address. So, you know, between my demo and demo 2, I might include a rule that allows demo 2 to send specific traffic to demo that I don't let anybody else send. Or I might include a rule that says anybody in this virtual network that I set up, the demodomain.ca, anybody in that network, I could say -s, this whole network, they're allowed to send that specific traffic. -d for the destination address, if I'm concerned about what address this traffic is being sent to, I would include -d. And the address that I include there, again, could be an individual machine address, could be a whole network. We won't use this as frequently as -s. Most of the time, when you're setting up a firewall, you're setting it up on a server, and you're doing it because, well, you want to allow people to send traffic to your machine. And that might include traffic from the entire internet. You know, your web server should probably be visible worldwide. So you probably wouldn't filter the, I was confusing myself with what I was saying there. Yeah, your web server that's visible worldwide, you probably wouldn't be filtering the source address. Your internal email server or a DNS server that's only supposed to be accessible to people within your organization, you might filter that source address. Destination address comes up more when, say, you have a machine that has multiple interfaces and you only want to accept this traffic on one of them, or if you have a machine that has interfaces into multiple networks, you might trust one of those networks more than the other. For example, I described, I think in the previous video, the way that I have my machines set up, the way I have my students set up their machines. You have a host machine that is running a virtual network, and you have several virtual machines inside that, which means that host machine has at least 2 interfaces. One that faces that virtual network, one that faces the outside world. Traffic sent to the address that is connected to that virtual network is probably a lot more trustworthy than traffic that is sent to the address visible to the outside world. -P is for the protocol. This is the network protocol used by this packet. So examples of that would be TCP, UDP, ICMP, or all. Again, there's a couple of other options that you could use there, but I'm not going to cover them. If you're using all, just don't bother putting this option in. Because if you leave it out, the default action is actually just all. If you don't specify, I care about the protocol, your rule isn't going to try to match a protocol. --D port and --S port. This is the port that the traffic is being sent to, that is destination port, or the port the traffic is being sent from. So S port, source port. I put these two in one bullet point because both of them are only usable if you've already put in the -P option and picked a protocol that uses ports. So TCP and UDP. You can't say -P ICMP and then --D port because the ICMP protocol has no concept of ports. Now, just like I was mentioning a few minutes ago, where you're probably more concerned, say, with a source address of who's sending you traffic, when you're receiving this traffic, you're concerned with the destination port, the port that this traffic is being sent to. That's what allows you to say, I'm accepting traffic to my SSH service, or my web service, or my email service, or whatever else. We generally aren't going to care much about the source port of who sent or where this traffic is being sent from, because for most services, that source port is random and not predictable beforehand. It's just one of the, 64,000 and some non-privileged ports on a machine. -I and -O allow us to match this packet to the interface that it arrived on, or with -O, that it's going out on. So again, this is really handy if you have a machine that has interfaces into multiple networks. You could say both, say, -D with the address, so the address it's being sent to, and that it must be coming in on the interface associated with our internal, more protected network versus, the one that faces the outside world that people might be trying to use to break into your network through. Both of these interface options, -I and -O, are only available in chains where they make sense. So you can't say -O for the outgoing interface in the input chain, because the outgoing interface has nothing to do with the input chain. Similarly, you couldn't specify the incoming interface in the output chain, because they're just unconnected from each other. And you can combine those options, or other options that you read about later on your own, you can combine those as needed. For example, if I wanted to allow ICMP traffic from a specific network on one interface, I can do that. I can specify the 3 options in one rule that would match that specific traffic. If I don't want an option, if I don't care about one of these things, I can just leave it out. If I don't care what source port it came from, I'm just not going to put in the --S port option. If I don't care about the source address that it was sent from, I'm just not going to put in -S. If my machine only has one interface and one address, I may not care about the -D with the address or the -I for the interface name. And so the real art of iptables that is going to come with experience is learning which options to combine to match the traffic you want, and the best way to learn to do that is by starting to match some traffic. So we can take this slide with this handful of common options, and again, there are hundreds of others that you might use, but these ones represent a really good start. And we can start thinking about the traffic that we want and combine those together and create a rule. So we know already from several slides ago which chain we want this rule to go in. We know what action we want to take with this particular traffic, and now we've thought about what is it that I am trying to match to allow or reject or block this particular traffic. So we can add this to a chain with iptables -I, the name of the chain. We put in one or more of our traffic matching options, and we -J for jump to some target. So for example, on my machine here, I mentioned earlier on, I don't want just anybody to be able to send ICMP traffic to my machine. I don't want just anybody to be able to try to SSH to my machine. Yes, I have limited the users that are allowed to log in. I've set up my key-based authentication. I don't even want the packets for other users or other machines showing up. So I can add in a rule to say, yes, I will accept this SSH traffic if it's from my own network, but not from anybody else's. So I can say sudo iptables -I for insert, and this is going to go into the input chain, and temporarily I'm just going to put in the -J and accept, because I do want to accept this traffic. The -J in your target does have to be the last thing on your command line. So I will move to just before that. So I've got sudo iptables -I input, and I will put in one or more of these traffic filtering rules. So SSH traffic uses the TCP protocol. So -P TCP. The port it's going to use, it is going to go to destination port 22. So the port associated with SSH. But I care about what address is sending this traffic. So I can say -S for source address and 192.168.122.0/24. So use that CIDR notation and specify my entire local network. And when I hit enter, it prompts me for my password to use sudo. No news is good news, but I should double check. So I will iptables -L again. And now I have at the top of my chain, because I inserted it, that puts the rule at the top, this new rule that says if it's TCP traffic and the source address is anyone inside 192.168.122.0/24 and it's SSH traffic, allow that traffic. If you're always using -I like that, you're always going to be adding rules to the top of your chain, but we've already discussed that the order of rules in your chains matters. So sometimes you will want to add a rule and not have it be the first rule in your chain. So what you can do when you say -I in the name of the chain is include a number after that to say this should be rule number whatever. And any rule that existed at that number or below gets pushed down, and this rule gets inserted in that spot. So maybe I don't want to have my SSH from my local network rule as the first rule in my chain. Maybe I want that to happen after this related and established rule. So I'm going to make it rule number 3. I'll just use my command history to go back up, and I will say -I input 3, and then all of the other options. So what will now happen, well, the existing SSH rule that I just added is rule number 1. That rule that deals with related and established traffic is rule number 2. The rule that was handling ICMP traffic from anywhere was rule number 3, but I just said add this new rule as rule number 3, so that ICMP 1 gets pushed down to 4, what was in 4 gets pushed down to 5, what was in 5 gets pushed down to 6, and so on. So if I list again, we can see as rule number 3, the one that I just added. We can also see as rule number 1, the one that I added about 2 minutes ago now. If I wanted to add a rule at the end of the chain, I can use, instead of dash capital I, dash capital A for append, add to the end. This does not allow you to specify a line number because, well, the end is always the end, whatever line number it is. So if I add that, and then we list my table, I now have another copy of that rule as the last rule in my chain. So again, this is where that dash dash line option that I mentioned in the previous video gets really handy. If I have a chain that's 30 rules long, that option, combined with dash L to list that chain, allows me to quickly see the line numbers of each rule. So now I could quickly say, oh, I really wanted that to be rule number 7, so it would come before this reject rule, or something like that. So now I have some extra rules that I don't really need and I want to get rid of. Well, dash capital D will allow us to do that. And you could use dash capital D, the name of a chain, and then all of the options that specify that rule uniquely. That's really difficult to do, to make sure you get all of the options exactly right. So again, this is where that dash dash line option is very, very handy. We can just say delete a specific rule number. So I don't really want this rule number 1 rule anymore because I've got now 3 copies of this. So I could sudo iptables -d input 1, delete rule number 1. And if I list, well, the thing that was rule number 1 is gone, everything else shifted up 1. And now rule number 7. I don't want rule number 7, it's a duplicate of rule number 2. So I will iptables -d input 7. And I look, 7's gone. Great. So I have this new rule number 2, the one that says SSH is allowed from my own network. So now I don't really need this one that is listed as rule number 5 that says accept SSH from absolutely anywhere. That's a terrible rule to have. So I will iptables -d input 5. Just a warning here, and I'm kind of demonstrating this as I go. If you're deleting multiple rules from your chain, either start from the bottom and work your way up so you're always, you're only affecting the bottom few rules, you won't affect the ones above them, or after you delete each rule, double check your line numbers. Because if way back here I had said, oh, this is rule number 1, and this is rule number 3, and I said, okay, delete rule number 1, it would make all of these rules shift upwards 1. So the thing that had been rule number 3 would become rule number 2, and if I said delete rule number 3, I'd actually be getting the thing that was rule number 4. In this case, I do want to delete that anyway, but, just double check your line numbers as you are deleting. So if I list, okay, I'm better protected for SSH. I still have this issue with ICMP though, that just anybody on the entire internet is allowed to send ICMP traffic to my machine? That's not a good idea. So I'll add another rule. So sudo iptables insert into input as, let's make it rule number 3. The protocol is ICMP. The source address, my local network, 192.168.122.0/24. Jump to accept. And if I look, there, I now have a rule that says ICMP traffic from my own network is allowed, but not from anywhere else. So now I can delete rule number 4, because I really don't need that. Now that's a reasonable looking set of default IP tables. Keeping in mind that, rule number 1 allows, when we have ongoing traffic, it's allowed to happen. If our machine starts communication with another machine and that other server respawns, well, that's established traffic, so that would keep this allowed without us having to figure out what are all the different things my machine might send out. Oh, wait, I realize this isn't perfect. I still have this reject rule that I probably don't need. iptables delete from input rule number 5. I could potentially add a new rule number 5 that says for any other traffic, if it's from my local network, reject. Possibly, if I wanted to, but I don't. But it might be a reasonable practice, so if you are trying to, troubleshoot and diagnose your machines, at least within your local network you can get responses from them, but not from anywhere else. Now, one last thing to do before we reboot. These rules we've written in iptables, as soon as I reboot, they're gone, unless I do something to permanently save them. There is a command that will do this for us, iptables-save. It outputs the information necessary to create my current rules, but as you'll see when I run it, it outputs it to the terminal. Oh, I can even get rid of my rule in my forward chain there before I save these. Give me a moment. And yes, you should have seen there. So I ran the command and I get a bunch of information on my terminal, and we can see the rules that I just wrote a few minutes ago, or the default ones that already existed for me. And we can see some of the other chains and tables that I said I wasn't going to talk about. So I'm going to get rid of that rule in my forward chain. This machine shouldn't be forwarding any traffic. So I'm going to flush my forward chain. And now if I get that output, great. The default policy for forward is drop, and I have no rules in forward that would allow any traffic. So what I want to do to actually save this output is just redirect it to a file. When the iptables service starts, it's going to read etc sysconfig iptables. So all I really need to do is get this output into that file. And then my rules are automatic anytime this service starts. Before I do that though, make a backup of those original not great default rules, so that if something gets horribly broken and you just need a quick firewall on the spot while you fix stuff, you could restore from that backup. Let's take a look at it for a second. Of course it needs elevated permissions. So you can see those default chains, input, forward, output, and you can see those default rules that existed for us. The one that says related and established traffic is okay, that ICMP traffic from anywhere is okay, that any traffic that arrives on the loopback interface is okay, that new SSH traffic from anywhere is okay, and anything else in input or forward gets rejected. Just a note, you'll notice I really haven't done anything with the output chain here. As a rule of thumb, unless you're in a very high security environment, we really won't do much with the output chain. We will sort of accept that traffic your machine is sending out, it is supposed to send out. In a very high security environment, though, where you might be concerned about if this machine gets compromised, it might then start being used to compromise other machines, you absolutely could change the default policy of output to drop and start writing rules for every single type of traffic that your machine should be sending out and blocking everything else. Now, I did say before we do anything to this file, we should make a backup copy of it. So I'm going to copy it to etc sysconfig iptables. I like to use .orig for original to indicate this is the original file that it came with, because somebody might come along and use .back to indicate it's a backup, and we don't want them to overwrite the original with a backup they've made of a different set of rules. So we've made our backup of those original rules. If anything goes horribly wrong, we could just copy that back into etc sysconfig iptables, restart the service, and we've got a functioning firewall. But I do want to save the rules that we currently had, so I will iptables-save out to etc sysconfig iptables. Iptables, if I type it right. Oh, because I used redirection and sudo doesn't like that. Alright. This is one of those few times where I'll switch you into a more permanent root session. And iptables-save, redirect out to etc sysconfig iptables. Now that worked, we can exit our elevated permission session. If we take a look at etc sysconfig iptables, it now has our new rules, and if we restart our service, iptables-l, it keeps that new set of rules that we wrote that keeps us somewhat more secure than the original ones. So what we've looked at in this video is the basics of configuring this somewhat older firewall for your Linux machines called iptables. There is much, much more that we could do with this command. There are so many other options that you could use to filter traffic. But even just the basics that we've covered here will allow you to better protect your machines. You can now block all the traffic you don't want and only accept the traffic that you do. Potentially, admittedly, in order to do that, you might have to look at the man pages for iptables or iptables-plugins to see, or is it plugins or modules? Well, read the documentation and find out to see what other options you might use to match very, very specific traffic. Thank you, and I'll see you in the next video.